Docker has released Model Runner. I'm going to break down what it is, why you should or shouldn't use it. We're going to go through some examples and some actual useful use cases for using this way to run LLMs. And then we're going to break down all the internals. How does it work? What is the magic behind all of this, and compare it a little bit to other tools. Let's get into it. Okay, first up, this is Mac only as of early April 2025, but Windows is coming. It should be this month. So maybe by the time this video drops, you'll have it on Windows as well as Mac. And then eventually they're going to support this in Docker CE. But essentially, the elevator pitch here is this is a way for people already running Docker to run LLMs easier than it might have been for someone new to learn all the other tools, right? If you've been running local models for your own use or on servers somewhere for your own use in a company or just as a hobby in your home lab, then you already know how the ways you like to run it, and there's not necessarily an advantage to make you want to move to Docker's way of doing it versus others. But there's a couple of interesting things that I think they're trying to do in the industry around standardization of how these models are packaged, and we're going to get into all that. But first up, let's just get it running so you can see how to set it up and run it for your own use. So first off, you have to have Docker Desktop, and it has to be a Mac as of today. I have to have at least version 4.40. I'm not sure if they're going to do a 4.41 for the Windows release, but on Mac, it's 4.40. And underneath your settings, under Features and Development, you will see a new option under Beta Features. Presumably, if you're watching this later, it will no longer be a beta feature. But you need to look somewhere for Enable Docker Model Runner. It's not Docker AI. That is the built-in AI chat that you can ask Docker's Gordon to help you write a Docker file or to help turn a Docker command into a compose file, stuff like that. That's been around for a while. That's not new, but Docker Model Runner is. The default ways you're going to access it include just inside containers that can access it through a host name. We'll get into that later, or through the Docker socket from the host, which is a new, interesting way to access it. But if you just want to access it from your host or even from remote machines, talking to your Mac remotely, you can enable the TCP port, which is 1,000. If you've noticed, it's 1,000 above Llama's port, which Llama runs 11.434 by default, and Docker is running 12.434 by default. So this is just in case I want to access it from the host directly. I don't need to enable that if I just want to use it from inside containers. Being that this is Docker, they are focused on you using this from containers primarily. It has way less features than a lot of the other tools you might use, like Llama or LM Studio. So I think of this as the gateway drug to a lot of those tools if you're not familiar with running your own models yourself. So this is easy. It's a typical Docker thing. It's easy to get started. It's easy to understand if you already have Docker basics, but it's not actually using containers to do all this. So we'll get into that architecture here in a minute. Once I've enabled it in settings, I can go back to my shell and I can confirm that this is working through Docker model status. And it just says Docker model runner is running. Now, I don't have any models yet. In theory, I actually do, but you don't have any when you start this. There's not any models coming with Docker Desktop by default. So we have to go to Docker Hub to get those. Now, this is a new packaging format for models. So all the other places you get models, Llama or anything else that's on Docker Hub, won't work unless they're converted to this new OCI artifact type. And that's the unique thing that I want to dig into is Docker's designing a manifest or an artifact type here that's just the minimum you need for the model. It doesn't come with the inference servers that you would use for maybe accessing the API like you would for OpenAI's API. None of that stuff's included. This is just the blob of the model itself and a license file like MIT or whatever. Sorry for the interruption. Just real quick, in case you didn't know, this content I'm creating has a little bit of a community behind it. So we have a very large Discord server, over 20,000 DevOps professionals. That's over at discord.gg/DevOps. You can find out all of this content I'm creating, including courses, course updates, blog posts I'm creating, all on my low frequency newsletter that's just about the stuff I'm making at bret.news. And I hope you like and subscribe here. It really does matter. It helps me know what videos are working and helps me get sponsors from all the supporters out there. So thanks for doing that. And of course, you can get membership for exclusive benefits. Check that out here on Patreon. And back to the video. So if we jump over to hub.docker.com, you will probably see somewhere the GenAI catalog. So as of today, when we're looking at this, you will see Docker models, and that's the new format for how these are going to work in the Docker model runner. You'll notice they're all under the AI account. So I can actually type in hub.docker.com/u/AI. That will take me in here to all of the models listed in, I don't know, popularity, alphabetical. I'm not sure what the order here is. When we're back on this main GenAI catalog, as you scroll down, you'll notice other things in there as well, including MCP servers, which are for tool calling with agents. We won't really talk about that just yet in this video, but we also have other things like applications that you might recognize and older models that won't work with this. And I'll show you what that looks like in a second. Then we have other, for LML frameworks, databases, orchestration, all the different parts of the puzzle. But for this video, we're just going to focus on running the models through the model runner. So we need to pick one. Up at the top, I'm going to just go to Gemma 3. And these are all the sort of popular models out there from the different main companies. You'll see Meta stuff here. You'll see some stuff from Hugging Face. And it's not entirely complete. If you go to Hugging Face or other places for models, you'll see a lot more, but those models won't yet work with this model runner. We don't really have import, export, or converting abilities, and Docker's invented a new OCI artifact way to store this, so it has to be in that format. In fact, if you want to see what happens when you pull a model that doesn't work with this, I pulled an older model from Red Hat's Granite, and it just gives me this. You'll notice, by the way, the Docker model is where all the new commands are going to be. So it's not a standard Docker pull, which probably would work with this because this is considered an actual container image, whereas these new models Docker has are OCI artifacts. They're fundamentally the same thing of manifest plus tarballs, but in this case, it's not going to work. So it detects that the manifest isn't what it expects. It complains about it being unsupported and that you should do better. So that would mean I can't run those. So as of right now, I'm sure that others will adapt to this new way that Docker's doing things and they'll update their models. But you need to look underneath the AI user in order to see this. And if you scroll down, you'll see some simple stats around the different tags for this model. And the VRAM usage is probably the most important thing to make sure that you have enough GPU memory to run this. I'm just going to pull the smaller one right here for Gemma 3. And the way we do that, of course, is with a pull command, only we're now going to do a Docker model pull and then that artifact name. And you'll see a simplistic downloader here. I do hope that Docker improves this because we don't know really how big this is by just pulling it. So I need sort of a Windows 95 style download bar to know how long it's going to take. So it turns out this one's pretty small at 700 meg. A lot of these can get up to tens of gigs in size. And now it's on my machine. Now I have pulled other ones, but I can do a Docker model list and see all the different models that I've downloaded. You can see their actual size here, which is similar to what they might need in memory. So that's kind of the way I can gauge whether or not that model is going to fit in my GPU. Now, because this is on Mac, and Macs, at least the M series, which are the only ones with Apple Silicon that can run these models, I don't think Docker's going to support old Intel laptops anymore, since those are over 5 years old at this point. But these models are using unified memory. So I'm on a Mac M4 with 48 gigs of RAM, but I struggle to run even this model on my machine this way. It's using, if you're into LLMs and all the details of that, this is using the GUF or GGUF format. And I think that's how you say it. GUF, gruff. There's no R in it. So that's not it. But, that file format that all the other ones use by default. If you're also really into this, MLX support for Apple Silicon is coming, which will give us a 20 to 30% performance boost, I'm told, but that's not here yet. So right now, these are all the same file design, and that one won't work for me. So I have to run something a little bit smaller. This one does work for me. And the way that I know it works is when I do a run. Now, Docker model run isn't something that you always have to use to launch the model. Remember earlier, the model status says it's Docker model runner is running. What that really is the inference server or the OpenAI API that provides you access to the various models. That's always running because we enabled it in settings. It's low memory usage. It's actually using llama.cpp, a very popular way to run models on your local system. And that's just running always. The models will be dynamically loaded and unloaded from memory in GPUs as I use them. And I can watch through my GPU memory and GPU utilization how these are spiking up and down as I'm using them. So I just paste in the model name here, and then I get an interactive shell. I could have also passed a chat prompt to the model runner, so I could just back out of this and say hi right at the end of that line. And then I will get a chat response. This is a little larger model, so it's going to take a few seconds before it will respond. But you can see that it gave me that response. If I just typed the model name, it actually, at this point, doesn't load the model. It's only when I present it with some tokens through this chat interface that it will then load the model. So what is DevOps in a short paragraph? So this is pretty fast. It's very comparable to the other tools that would run these gguf files. But I find this chat interface to just kind of be useless. It doesn't have memory. It doesn't have history. You can't ask it to remember something and then recall it in the next prompt. So it's really just cool for a demo or a single one-shot question to a model. The real interesting thing here is how we can access the llama.cpp API directly. So all the various tools out there that can talk to ChatGPT or that style of API, those all can work against this model runner, just as if you were running Ollama or LM Studio or something else. And I think that's the more interesting way to use this. I don't see myself ever using this chat in here. We're going to do an install of Open WebUI, which is essentially a ChatGPT clone that does make this pretty useful. It allows you to select the different models. It has history. It has memory. It can save all that into a volume. You can access it remotely through something like Tailscale. It's actually pretty useful. But from an operator and DevOps perspective, I'm very interested in how all this is actually working. So the first thing I should tell you is this is not all running in containers in the Linux VM. In fact, let's go to a diagram and let me show you how I see this all working. So today you might have Docker Desktop on your machine. We're just going to say it's Docker Desktop on Mac. I need to have at least version 4.40. I have a Linux VM, that's how Docker Desktop runs all the Linux containers, running in the background. And Docker manages that transparently, and it's a little Linux VM. You might have the Docker CLI, and it's talking to the engine, just regular Docker run commands. And then the GUI is also talking to the Docker engine. And you get all these features that we all know and love today. But with Docker model CLI, we're using a plugin. So anytime you're using a model command, it's actually using a different plugin binary. If you're not familiar with that and you just type a Docker info command, you get a list of all the plugins for the various additional features that the Docker CLI will support. And we have this llama.cpp running in the background on my Mac. So we'll call that the model runner service. And the way I see it is the CLI talks to the model runner for you rather than to the Docker engine inside the Linux VM. And that means that the models are not running in the Linux VM. They're actually stored on your host machine in this directory of your user, .docker/models. We'll take a look at that in a minute. And I might have a couple of models already stored there that I've downloaded with the pull command. That runner service is controlling the models dynamically loading and unloading when I need them. Now, how I access this llama.cpp API is if I'm on the host, I'm going to access that through the TCP port. If you remember, I could curl that 12434. I would get back a response. So that is technically talking to this llama.cpp for me, at least on my machine, because my firewall is not turned on. If I wanted to talk to my Mac from another machine on my network or over a Tailscale network, that all works with this port listening on the physical network. And for my containers inside this VM, they access it through a different URL, the hostname model-runner.docker.internal. And you can think of that as pointing directly to that llama.cpp as well. Now, this is very similar to how Llama and other tools do it. They put things in different places, but they can be accessed from inside containers and as well as the host. So not terribly unique, but at least it is a consistent command line interface. Now, if we go back over and look in that directory under .docker/models, because I've got all these models installed, I have manifest files, which you can see are pretty small. And then I've got the models themselves, which are going to be pretty big. I believe that there's also license files in there. So when you see short little small files there, they are just license files probably. And when I do a Docker model RM, it will delete those files off the hard drive to save space. Now, because this isn't working inside the container engine, a lot of the things that you would maybe try to do with this aren't going to work. So you can't prune these images yet with a Docker system prune. You won't see them in a Docker system DF for file space. You won't be able to see them listed as containers or images with the standard commands. You just won't see it anywhere outside of the Docker model command line. And if we just type Docker model, you'll see that there's only the 7 commands we have so far. And eventually they're going to have a push command. Presumably we're going to get more of the features that you would expect out of something like Llama, where we can possibly make these artifacts out of models we've built ourselves or have locally on our host, and then we can push them to Docker Hub, but none of that exists yet. Now, if you really want to get into the nitty-gritty here, which I find to be equally fascinating to the fact that we can just run these things through Docker now, is I can use something like ORAS, which is an OCI artifact tool that I can create or look at or inspect or pull or push OCI artifacts, which are essentially everything that you would store in a registry that isn't a container image. And I pulled one of them, and you can see here it's got a series of files, and I can look at the index, which is interesting. But as I go into the blobs, for this particular one, that's a binary. That is the model itself. It's 256 megs. And then I have the license file as another part of the artifact, and then more schema and details. For example, this one is where we get all the details we would see in a Docker model ls command, including the quantization of it, the format of the model itself, how big it is, the architecture that it came from, all those details for humans. And we can also inspect these things with various tools, including Docker Manifest. So if you were curious about how these are different from true container images that would have binaries in them to run servers, you can inspect on something like, let's just do Alpine, right? And I'm going to pass this through JQ for pretty colors. And you can see that this manifest is actually a manifest of manifests. That's a very normal thing for container images. This isn't necessarily meant to be a deep dive into how manifests work, but if you go check out my blog article on OCI artifacts, you will see more details in there on how artifacts are different from images. Something that's mentioned in there is how manifests depend on other manifests. And in an actual container image, you typically need to pick your platform, and then you can go inspect that one. So we can do that. And the way I would do that here is under Alpine, I would put an @ sign and then that SHA hash, and then would go to get that specific architecture. And I can see more of the stuff you'd kind of expect from an image, including which architecture it's for, what's the image source. This is all the metadata that you would see as annotations or labels, the version of that application, and then the layers itself, which in this case with Alpine, it only has a single real layer of data that's about 3.6 meg. But if we were to take one of the model names and do the same thing with it, we're going to get different results. Let's do that in JQ for prettiness. And you can see in this one, the media type is the same at the top, but once we get into config, this is where OCI artifacts define their media type. And you can see that Docker's created a new specification of docker.ai.model here, and that there's only 2 layers. One of them is the license file, which has its own media type. So that's part of the definition that I guess they're trying to standardize. It's only 8K in size. And then we have the GUF file and its size there. So I'm assuming that all the different models are going to look very similar to this, and that once we get other types of AI images, this will be different. I suppose you don't have to have a license file, so that might be absent, but much easier for these artifacts in terms of the amount of manifest versus a true container image. That's why they can't really coexist. You can't pull down these files in with a Docker run command. In fact, if I tried to do that, it won't work. If I did a Docker pull rather than a Docker model pull, it's going to give me an error because that is not a true container image, and it should detect that and fail to pull it into the Docker engine. And as I'm saying that, it's sitting here and doing nothing. So to me, that is a weird quirk. If I tried to do the opposite and Docker model pull Alpine, it will give me that error complaining that it's an unsupported artifact type. All right, let's do something useful with this. If you don't know about Open WebUI, it is a pretty easy container to run, and it will give you a ChatGPT experience. You can have authentication, logins with saving of settings, and it's quite feature rich. I have not used it too much until using it now with Docker, and I'm actually really impressed with how much it feels like the paid experience that I paid to OpenAI for. And I've created a simple compose file for you to even run this more easily, because their documentation, like so many others on the internet, haven't been updated for how to specifically use it with Docker Model Runner, but it absolutely is supported. All we have to do here is give it a few environment variables. So you will notice that we're specifying the Open WebUI image. We're going to listen on port 3000 on my Mac. And these are the 2 environment keys that will save you time later, that you don't have to go into the admin settings panel and configure all this stuff. So it's basically telling it we're going to use the OpenAI API standard, and that this is the way to get to it. I don't need an API key, so you can put anything you want in there. We're going to create and save the data to a volume, so you'll have chat history and all of your user account settings and various other settings. So let's jump into that. I'm just going to do a Docker compose up. And by the way, you'll notice that this doesn't manage my models in Compose yet. That's not something that they've talked about, but I can see how in the future we might be able to download models or control models from inside a Compose file. But for now, I'm just going to do a Docker compose up, and then jump over to my browser and go to localhost 3000. And it will spin this up, and it will want me to sign in. Now, for you, the first time, it will ask you to create an admin account. For me, I'm using my email address and a very simple password. And once I'm logged in, I can choose my models. So this tool will accurately find all the models that I've downloaded into Docker Model. That's part of the OpenAI API standard. And I can choose one here, assuming that it won't kill my system memory. I'm just going to use that one. And then I can ask it questions. And on this bigger model that takes my system memory of 48 gigs up to 65% used, because that's also GPU memory. So it took a couple of seconds before it started responding, but it works. And like I said earlier, if you've enabled a TCP port, it'll be available on your local network, assuming your Mac firewall isn't on. And if you want to access it remotely, I was doing this from my iPhone over wireless using Tailscale that just happened to work fairly easy. So as long as you have these specific URLs, and if we go look at the Docker docs for this, they're quite complete. And you can scroll down and see the list of API endpoints. I refer to this often because it's not a complete list of everything the OpenAI supports, but it's enough to get us going. I mean, most of the stuff that your apps are going to be using is the chat completions, these things right here, the post, and then getting a model list. And possibly in the future, we'll have tools that are Docker model aware and will manage models possibly by adding them or deleting them through their own API. All right, coming soon. What's next for Docker Model Runner? Well, later this month, we should have the Windows version. Eventually, we're going to have the Docker CE version so that you can run it on a Linux system natively without Docker Desktop. I don't know how that's going to turn out because a lot of these things are running on the Mac and Windows hosts. So seeing how they're going to be running in Docker Engine and whether things are truly in containers or not will be an interesting thing to see when they were launched. There's no date for that yet. Other things that are happening is they're working on MLX support for Macs so that we'll get a 20 to 30% performance boost there. The Windows version will come with NVIDIA drivers so that it's sort of a one-stop shop for setting this all up and running. Docker has thrown out ideas around possibly putting in a GUI in the Docker desktop to have a chat interface with it, although the Open WebUI is quite feature-rich and easy to get started. And creating models inside of these OCI artifacts and pushing them up to Hub is something they plan to add to the CLI as well. Some of the troubleshooting or issues that I've experienced right out of the gate, because this is a 1.0 beta release, is that if you're using the Docker model run, which again, I don't think really any of us are going to be using that unless they greatly enhance the functionality of how that works. The arrow keys won't work in there, so you'll get some funky response. And that doesn't remember any of your queries, even if you ask it 3 things in a row and say, remember that, it won't remember that. If you leave, everything's gone, which I just find that it ends up making it rather useless. If you have issues with models being too big, you will get an error, basically a timeout, and that's your way of knowing that the model took too long to load. Some of the other issues I've had is sometimes I've had really big models either freeze on load, and it will cause me to actually have to restart Docker. That's only happened a couple of times. If you try to type Docker model and it says Docker model is not a command, that's okay, because really all these different subcommands of Docker that came ever since 2018 are all just separate binaries that are symlinked inside a certain directory. So Docker in their docs has some known issues that they're going to keep up to date down here, where you can just create the symlink to fix that Docker model not recognized. And I have myself a list of questions for Docker, so I'm going to be meeting with the team over the coming weeks as I get more of the details on the internals, how this thing works, and what might be in store for the future. So thanks for watching. I'll see you in the next one.